Let's look into resistance in the world of current. So we understand resistance as opposition, right? As of now, we understand it that way. And we understand current as flow of charges. So combining these two is not a big deal, is it not? Opposition to flow of charges is nothing but resistance, as simple as that. Can we measure resistance of different materials? Yes. And there are list of resistance offered by different materials that is available. You have it in your syllabus. You should not be memorizing that. And we can web search as usual. How do you measure it? Well, we have complicated devices like something called as Wheatstone bridge, galvanometer, right? We can measure things directly and indirectly with that. So that is not something which we'll be looking at. That is a topic for the future courses. For now, I'll be just using something called as multimeter. It's a very easy to use device, quite not that costly as well. It works. It's the working is very simple. You have a knob, turn it towards whatever you want to measure. You can, by the way, you can measure voltage with this, current with this, and resistance. That's why the word multi. So, making use of it is not that hard. You just have to turn the knob towards whatever you want to measure. In this case, I want to measure resistance. So I have to turn it within this range. Take these two terminals and touch the things which I want to measure. I'll be showing that. Okay. So we are using multimeter to measure things over here. So a small note to people who are interested in building small projects using LEDs or maybe complicated versions like a robot, small robot, a robot which you put, give it some direction and it moves, or something like a drone, right? Complicated version. So we have to make use of multimeter. It helps. Okay, now let's look at few examples of me measuring things and let's look at the values. So to begin with, I have a connecting wire. So it measures around 150s. Next, we have a motor. So this is around 340, right? Next, we have a bulb, um, 180. And next is a switch. So first thing what I'm doing is I'm switching it off, right? That is switching it off. And when we measure it, we have 1. What does it mean? I'll explain. Now I'm switching it on and then measuring, right? I'm switching it on and now measuring. So there is no 1, but you have a value like 150. Makes sense. So I'm taking up a wire which is insulated. So I'm measuring the insulation. Clearly, again, that one thing is coming and connecting to the ends, the conducting path, and we have a value less than 200, right? So coming back to the board, what you just looked at was different materials, and we saw values which is around 150s to 250s. So let's make a small note on high values, you know, value with value like infinity. So this device measures infinity or shows infinity as 1 in the left extreme. That's what you saw. In multimeter, you saw ones, right? When I switched it off, when I switched off the switch, it measured 1. That means it's showing infinity. What does it mean? There's no flow of current over there. It's highly impossible for that for the current to flow. No flow. Example is switched off anything. Any switched off circuit shows infinity. Rubber, air, right? They are bad conductors. Indirectly, we're telling high values means equal to bad conductors. It's a better meaning, right? So if a device shows infinite measurement of resistance, means they are bad conductors. Of course, exceptions are there wherein you have really high voltage and things melts and all of that happens. So that's a different case. We're talking about normal introduction case. And you can have values of zeros also. Even this is not in your syllabus, but I would like you guys to understand this. If you see a resistance of 0, it means it's a very good conductor. Not just good, very good conductor. It means there's no resistance. Like literally there's none. And yes, it's not something that is available in the market. It's still not yet commercialized. Example of this is something called a supercomputer. Super, not computer, sorry, conductor. Okay. It's an exception, right? So very simple introduction to resistance. And in the next section, we'll be looking at measuring resistance of wires. Okay.